This is the second video involving interest rate swaps. I will invite you to pause the video here, copy down the material on the board, and then I'll talk us through it. All right, so in this video, we seek to figure out how to determine the swap rate C. This swap rate has to be determined at the beginning of the interest rate swap time zero. So we have to use interest rate information that's available to us at time zero. Okay, so to determine C, we're going to set the price of the float rate bond equal to the price of the fixed rate bond. If you recall, this is one of the conditions of an interest rate swap that we covered in the first video. Right, so we're going to set those two prices equal to each other, and then we're going to solve for C, the swap rate. Now, the nice thing about the float rate bond is it's easy to figure out its price. In the float rate bond, the coupon rate is always the current market rate, which is the 1 period spot rate. This means that the float rate bond is neither premium nor discount. It's exactly priced at par. You can think of the coupon as exactly paying off the interest accrued each period, right? So the price is par or the face value or the redemption value. Those are all going to be the same, and we'll just denote this F, okay? Now, for the fixed rate bond, we've got our fixed coupon rate C, and we're going to price this bond by using the various spot rates that are available to us at time zero to drag the money back. So here's my time value diagram of the fixed rate bond. I have coupons, face value times coupon FC at times 1 through n, so period 1, period 2, end of period 1, end of period 2, end of period 3, etc. And at the end of the bond, we've got our coupon plus our redemption value. Now, it might be hard to read, but this first coupon, I'm going to drag it back to time zero via the 1 period spot rate S1. This bond that arrives at time, this coupon payment that arrives at time 2, I'm going to drag that back to time zero via the 2 period spot rate S2. And the coupon that arrives at time 3, it gets dragged back 3 periods using the 3 period spot rate. And all those spot rates are available to us at time zero via Bloomberg or newspaper, whatever you like, okay? All right, so let's set the price of the two bonds equal to each other. On the left, I have the price of my float rate bond, F. And on the right, I have the more complicated price of my fixed rate bond. So I'm going to abbreviate it since we're using different spot rates at different time periods. I'm going to say the coupons are forming an annuity immediate, and I want their present value. I have N coupons, and I'm going to be using the spot rates to drag them all back. So that will be my notation for dragging back all the coupons to time zero using the various spot rates in effect for each period, okay? And then my final redemption payment, F, at time N needs to be dragged back N periods using the time N spot rate. Okay, so that would be the annual effective rate that takes us forward, or the period effective rate that takes us from time zero all the way up to time N periods. Okay. All right, well, everyone's got an F in it, so I'm going to factor and cancel out an F from both sides. And then I get to this expression, and then I'm simply going to solve for C by subtracting the spot Vn to the left and then dividing by the annuity immediate's present value. So I get this lovely formula for how we can set this swap rate at time zero to start off this whole transaction. All right, so let's see it in play. So at time zero, we open up our Bloomberg terminal, and it's telling us the annual effective interest rates that are available for a 1-year loan, a 2-year loan, and a 3-year loan, or a 1-year zero coupon bond, a 2-year zero coupon bond, a 3-year zero coupon bond. Okay, so let's say it's 3%, 4%, and 5% respectively. Let's use this information to do part A, determine the swap rate for a 3-year annual coupon swap. Okay. Well, so here's the formula that we just derived on the previous half of the board, and I've replaced N with 3, so it's a 3-year annual coupon. V cubed, that's supposed to drag money back from time 3 years back to time 0 years. So I'm going to use the 3-year spot rate of 5% and cube it. And if you like, I could imagine there's a $1 here that's being dragged back for those 3 years. And in the denominator, I got the present value of this annuity immediate. Okay, So, and I can also imagine that I've got payments of $1 at the end of each year, right? So there's my first dollar time 1, and to drag it back to the spot rate, I'd use the 1-year spot rate applied for 1 year. At time 2, I've got another $1, and it has to get dragged back 2 years, and I'd use the 2-year spot rate to do that dragging, and then similarly for time 3. Okay. All right, so I cranked that out, and I got a C value of 4.935%. So that is the fixed rate coupon for this 3-year annual coupon interest rate swap. All right, so B, let's suppose that the two parties agree to a fixed value of $100,000 and this C value of 4.935%. They enter into this 3-year interest rate swap. 1 year later, they go to see what's going to happen. So at time 1 year, the advertised 1-year spot rate is 5.5%. And we can now use this to figure out what happens when the next coupon at time 2 gets paid, right? So the payer, they are going to pay the fixed rate coupon, 4.935%, 100,000. They're paying it, so it's negative. And they're going to receive the floating rate coupon. Now, at time 2, the floating rate was that 1-year spot rate that was in existence from time 1 to time 2 during the second coupon period. So we're going to use that 5.5% the floating rate coupon times the face value. And that turned out to be a net positive of $565 for the payer. Now, the other party, the receiver, they receive the fixed rate coupon and they shell out, they pay the float rate coupon. So they're going to be down $565 at time 2. All right. We could have also, with some more information, we could have figured this out for time 3, 4, 5, or time 3, I guess. At time 1, we can already figure it out. At time 1, the coupon that the floating rate payer will pay is based on the 1-year spot rate that was in effect during the first coupon period. So from time 0 to time 1, we knew that rate was 3%. So at time 1, that first coupon, the payer would shell out the fixed rate and would receive the 3% of 100,000, and the receiver would be the opposite. All right. Okay, well, hopefully that works, and there'll be some more videos on more complicated examples.